Okay guys, ready for a new Monday lesson. So we're still working with vectors. This assignment is going to start out seeming possibly kind of complicated, but then when we get to seeing what's going on, I think you'll find it's just kind of putting together stuff we've already done. I am going to use number 2 to explain a lot of stuff. So the amount of work that I'm going to go into number 2 is not going to be what you're expected to do on every problem. Once I get past number 2 into 4, 6, and 8, and 10, I'll have it a much more streamlined process as to what you're going to do. But here in number 2 is where I'm going to explain a bunch of the theory that's going on. So draw a vector diagram, which we haven't done yet. Well, we've kind of graphed vectors, but a vector diagram's a little different. To find the resultant of each pair of vectors using the triangle method. So resultant is when you add two vectors together. The triangle method is just a diagramming method to show what vector addition really looks like. So a big chunk of what we're doing is going to be drawing. Then we need to state the magnitude and direction of the resultant vector. So we've already done direction and magnitude, so that's going to be a repeat. The resultant vector is going to be like the outcome of the drawing. So for number 2, we've got two vectors, 7, 6, m, which I have drawn here, and 9, negative 12, which is n, which I have drawn there. And we're supposed to draw what it looks like when you add them together, m plus n. Well, when you do this diagram, you don't actually draw both vectors in the proper position. So m is first, it does start at the origin, and it goes to there. When I want to add n to it, what I really want to do, now let me see if I can do this, is I want this to be drawn from the end of m. So n is not here anymore, it's over here. That arrowhead didn't go with it, but the arrowhead ends right here. So the question is, what are the coordinates of that point? So for m, I went over 7 and then up 6, plus n, I went over 9 and down 12. That negative 12 would be down 12. And where I end up is, if I drew everything properly to scale, I end up at the point 16, negative 6. So you can see that this lines up with 16 here and negative 6 there. All right, my drawing skill isn't that great. But so when you add vectors, basically you draw the first one first in the proper position, and then the second one gets drawn from the end of the first one, using those two numbers as a horizontal and vertical sort of counting numbers. All right, I'm going to erase some of this clutter that I've drawn in. The resultant, I'll draw in purple, because, you know, red and blue makes purple. The resultant is from the beginning point of the first vector to the end point of the second vector. So this purple is m plus n. That's the resultant. Now, the triangle diagram is what you see there. Clearly, it looks like a triangle. It's normally done without graph paper. You can do a rough sketch without graph paper, and rough sketch is good enough. That's, you know, totally fine with me. However, I still like to do the graph, sketch in some sort of a graph paper. I think you'll see why, excuse me, as I do more problems. But you can totally do this without any sort of graph paper, and it'll still work. So, but the point is, you can also find the resultant by adding these together. I mean, over here, resultant is m plus n. So I can do 7, 6 plus 9, negative 12. You can get the resultant of, 7 plus 9 is 16, and then 6 plus negative 12 is negative 6. You can totally get the resultant, the same answer, without a picture. The picture is just an exercise in getting you used to drawing a vector diagram and understanding what the triangle method is. So that is going to be part of the assignment, that you need to sketch that out. But here, let me scroll down to the answer key. And we're not even halfway done with this, but the answer key, you can see their vector diagram is right here, number 2. If I were to try to carefully draw in an XY axis here, it would look fairly similar to what I have drawn up there. Okay, that line is off, but how good do I want to go? This is just You know, so my answer, which I did on graph paper, their answer, which doesn't have graph paper, you can see it's pretty much the same answer. So you're going to be sketching these triangles. Use a little XY axis if you want. I don't have graph paper provided, but you can sketch it out like I did, or don't. It's up to you. Then we got to get to these two answers here and here. Okay, so what are they? Well, again, we're supposed to find the magnitude and direction angle. So magnitude, that's going to be the easy one. Magnitude is just the Pythagorean theorem, square root of 16 squared plus negative 6 squared. So I'll go ahead and do this, square root 16 squared plus parenthesis negative 6. Remember, with a negative you need a parenthesis. And I get 17.09. Is that what that answer was down there? Yep, 17.09. So we had a whole assignment on that. I think you breezed through it. Should have been pretty easy. And we don't need to keep the answers in radical form here. We did do that on the first assignment, but a decimal is good enough. So we got that. Now the direction angle. Okay, so the direction angle, remember, it was the inverse tangent of y over x. So that's going to be negative 6 over 16. So function, let me make sure I'm in degrees. Oh, I got too many menus open at one time. Okay, I am in degrees. All right, so function inverse tangent negative 6 over 16, and I get negative 20.56. So this angle right here, negative 20.56 degrees. See, if we didn't have graph paper, it'd be kind of hard to tell exactly what that angle was referring to, but now we see it's basically a reference angle like we learned about in trig. So that's why I like to have the graph paper here. But if I check the answers, is negative 20.56 the answer? No, it's not. So what's up with that? Well, back when we did direction angle, we talked about how if we have a vector in this fourth quadrant, I almost said third, in this fourth quadrant, we actually need to do 360 minus that angle. Oh, I did another dumb thing also, didn't I? I said always just use the positive numbers here. Duh. And you get positive 20.55. So the reference angle here, it's in the negative direction, but you know, that negative you can, oops, that was dumb. I'm not going to be able to erase that negative sign perfectly, so we'll just make it right there. But anyway, when you're in that quadrant, I kind of got off track. Even though this works out to be 20.56, your actual vector angle is 360 minus 20.56. Remember, in that quadrant, you subtract from 360, so let me do that. And we get 339.44 degrees. Let me check the answer. And there it is. So we've got our triangle picture. Mine has the XY axis. The answer key doesn't. I recommend using it. We can find the resultant just by adding up here. You don't necessarily have to count individual points if you don't want to. Magnitude is a Pythagorean theorem right here. Vector angle is inverse tangent, and then like I started to say, I got sidetracked. When you're in this fourth quadrant, you need to subtract your angle from 360. So here, where can I do this? Let me just do a little diagram up here. When you're in this quadrant, it's 360 minus the inverse tangent of y over x. When you're in this quadrant over here, the third quadrant, it's 180 plus the inverse tangent of y over x. Up here in this quadrant, the second quadrant, it was 180 minus the inverse tangent of y over x. Wow, that's sloppy, but hopefully you understand what that means. And then if you happen to have one up here in the first quadrant, it's simply tangent inverse of y over x. And then, like I said before, when you're doing that inverse tangent, you can just sort of disregard any negative signs like it was on that negative 6 right there when you plug that into your calculator. So that's all the tools and the knowledge you need. Number 2, I did a ton of explaining, but number 4, let's streamline this and see, what it is that we're expected to do here. So, Okay, so we're interested in the resultant, t plus u. What is that? Well, we can just go ahead and calculate it really quick. 8 plus negative 9 is negative 1. Negative 15 plus 8 is negative 7. So there's our resultant. If we want to draw this, what's it going to look like? Well, I'm going to go ahead and put a little xy axis down. If you can do it without, bless your heart. But 8 negative 15 is over 8 down 15. So let's say somewhere like here. There's our first vector. And then negative 9, 8, I want to go left 9. So I want to go this way 9. Okay, so if I'm over 8, I just need to go one more. And then up 8, which takes me right around, let's see. If that was negative 15, if I go up 8, it's going to be a little more than halfway, so right about there. And then if I connect these end to end, let me change colors here just for a little effect. That is my resultant vector. So what I should see when I check the answers down below is a triangle diagram that looks like that, except it probably won't have any xy axes in it. So it's going to look kind of like that. Number 4, let me check. And there it is. Really close, really similar. I'm not drawing to scale. I'm not using actual graph paper. Now let me hit the undo button and put this back in. Because when I have this diagram now, when I get to the step where I'm doing the angle, I can clearly see that I'm in the third quadrant. When I don't have this in here, I guess maybe you could reason through that that would technically be in the third quadrant, but this way you can see third quadrant. Okay, so there's our diagram. I'll leave it up to you whether to do the xy axis thing. The magnitude, I'll just do mag for magnitude. It's the square root of negative 1 squared plus negative 7 squared. I'm not going back to these numbers right now. I'm just going straight from those resultant numbers. So what is the square root of negative 1 squared plus negative 7 squared? It's going to be the square root of 50, which is 7.07. And before I get too far ahead and carried away, I'm going to scroll down and see if I'm right. And there it is. Looks good. Now the angle. So I'm going to do the inverse tangent, function inverse tangent of y over x. So that's going to be 7 over 1. Technically negative 7 over negative 1. Disregard those. And we come up with the fact that this angle right here, the reference angle, is 81.87 degrees. But in that quadrant, we have to add another 180 degree angle to it. So direction, did I write it that way up here? No, I didn't really call it anything. Here I called it magnitude, but I didn't really label my answer there. But anyway, so the direction is 180 plus that 81.87. So I just come down here and go plus 180. No, that's times 180. And I get 261.87 degrees. Let me scroll down. Whoops. 261.87 right there. Okay? So those are the three things we're looking for are this triangle diagram, the magnitude answer, the direction answer. The way you set it up, if you write magnitude or direction, show the formula, do it on the calculator, whatever. I'm not too concerned with that. Show the xy axis, don't do the xy axis, that's up to you. But I'm going to do number 6 now if this were my own homework assignment and I'm the student. So m plus n is going to be what? 5 plus negative 6 is negative 1. 10 plus 8 is 18. So I need an xy axis here. I don't know, just playing with the colors. So I need to go over 5, up 10. So I'm just making, a random semi to scale. I try to go up twice as high as I went over. 5 5 and 10, you know. Then from there I need to go down 6, so right around here, and then over 8, so maybe this far, which takes me to there. And then I'll do another fun color here. So I connect the beginning point of one vector to the end point of the second vector. That's what you get when you add them together. That should be my triangle diagram for number 6. And that's not even close. What the hey? What? What the? Did I draw it that far out of scale? Oh, I'm dumb. What a maroon. Jeez, oh Pete's. Let me just... Alright, just like in the classroom. My first vector was right. Over 5, up 10. Yes. What did I do on my second vector? I counted yx instead of xy. Okay. So, yeah. Here, let me do it as though I was a student. If I was a student, I'd be failing this class. Alright. So, my second vector, n, here, which I'll do in this blue color, I need to start at the end of the first vector, and I need to go left 6, up 8. Left 6 takes me over to here, doesn't it? Yeah. If this was 5, then negative 6 would take me 1 over. And then up 8 is going to go up, oh, I don't know, right around there, and connect those end to end. I get that. And then if I pick another color here, oh, not red, I already used red. From here to here gives me something that looks kind of like that. Let's get rid of that dot. So my diagram is this. Let me move it down a little bit. So now, when I check myself, the triangle, let me delete the XY axis just temporarily. Number 6. In there, that's a lot better. That looks like that. Okay. Sorry about that little blunder. Hope it doesn't throw you off too bad. And then, I mean, look, the coordinates of the final vector should be negative 1, 18, and this does look like it's left 1, up 18, so, you know, kind of makes sense that it would be there, not the way I had it first drawn. Okay, so there's that. Now let's do the magnitude. The magnitude is the square root, negative 1 squared plus 18 squared. So... yes, if I was a student, would I use a calculator? You bet I would. Square root negative 1 squared plus 18 squared. Oh, that makes sense that it's just a little tiny bit bigger than 18. This works out to be 18.03. And I'll circle that, and I will check that on number 6 down here. Yep, right there. Okay, and then I'll just check ahead of time. 93.18, that should be my angle. And it does appear to be slightly bigger than 90 degrees. So, but let's go through the actual process. So for the direction, here, I'm going to use MAG for magnitude, DIR for direction. I need to do the inverse tangent of 18 over 1. Remember, we don't use the negatives. So, inverse tangent 18 over 1 is 86.82. So that means that this angle over here, let me pick another color. This angle over here is the one that's 86.82. If I subtract that from 180, so 180 minus this, I get 93.18 degrees. And we checked that ahead of time, but just because I'm sometimes paranoid, yep, there it is, 93.18. So, again, to me, having the XY axis is critical in doing this whole thing. It's okay. It doesn't mean their triangle diagram is wrong just because you have an XY axis and these answers don't. Okay. So I screwed up number 6 a little bit. Let's try for perfection here on number 8. So I'll do my XY axis in black. And if I need to, I can always move it around. My first vector, which is A, straighten that out a little. A, let's do A in red. So 15, 17 is going to start at the origin. over 15 up 17, we'll call that right about there. Drawn to scale, no, but you can imagine 15 little marks here, 17 little marks there. Not going to do it. Okay. My vector B, let me do that in, how about blue? Okay, so from here, I go 9, negative 3. I have to go horizontally 9, down 3. So, and remember, if this is 15 and this is 17, so 9 isn't going to be that far. Well, it might be a little bit farther. Negative 3 is going to be very short, so that might just take me to there. Now get rid of those little dots. Connect these end to end. I'll use purple for red and blue. Connect these end to end to get my triangle diagram. And that, cross my fingers. I didn't screw anything up. That's what it should look like on number 8. And there it is. If I had an XY axis in here, if it just so happened to be like that, that's what my diagram is. So very happy with that result. Let's go ahead and check the answers here before we do them. So we're looking for 27.78, 30.26. I don't know if I'll keep those in my short-term memory or not. Probably not. Let's do magnitude. So it's the square root of, oh, well, look what I didn't do here. A plus B. 15 plus 9 is 24. 17 plus negative 3 is 14. Is that right? 24. Okay. Let me do my Pythagorean theorem. Square root 24 squared plus 14 squared. 27.78. So 27.78. And then for the direction, dirt, no, just dir. Okay, we are in the first quadrant, so whatever I get is the answer. I don't have to add 180, subtract 180, subtract 360, none of that funny business. I just need to do the inverse tangent of y over x, 14 over 24. So, function, inverse tangent, 14 over 24, 30.2, that 5 rounds up to a 6 degrees. Check the answers. And we got it. So I think what I had been doing is adding these first, and then I forgot to add those first on this one. It didn't hurt anything, but I would stick with that idea. Add them first to get the resultant answer. Do the diagram, do the magnitude, do the direction. Don't forget with the direction, sometimes you add 180, subtract 180, subtract from 360, stuff like that. Okay, one more. Again, to see if I can do this smoothly so that you've got a really good example to follow. So, t plus u, 12 plus 12 is 24, 16 plus negative 3 is 13. Wow, it looks like 10 is going to be almost the same as number 8. Oh well, sometimes you get a lucky break where two problems are almost the same. So here's my y-axis, here's my x-axis. Do this in blue. 12, 16 over 12 up 16, let's say takes me to right about to there-ish. Okay. Switch to red. Now I need to go over 12 more, but down 3. So right about there-ish. Get rid of that extra dot. Switch to purple. Connect end to end. That is what we call the triangle method. And that should be our t plus u there in purple. Let's see if that diagram is right. And it looks pretty similar, so I'm going to call that okay. Magnitude is the square root 24 squared plus 13 squared. So square root 24 squared plus 13 squared equals 27.29. 27.29. The direction is the inverse tangent of y, 13 over x 24. Remember, if either of those were negative, you just disregard the negative. Inverse tangent 13 over 24, 28.44. And that would be this angle right here, the reference angle. When you're in the first quadrant, the reference angle is the angle. So 28.44 is it. Okay. So, number 2, I explained a bunch of the ideas behind what's going on. From there, tried to streamline it into a process. Add the two vectors together. The resultant is always adding. You might say, why isn't it subtracting? If we wanted to subtract, we'd just make the second one negative and still call it adding. So don't worry about that. Add them together, you get what you should expect it to be. On an XY axis, approximate a picture doing this triangle diagram. Do magnitude using the Pythagorean theorem, direction using the inverse tangent. Don't forget that the direction angle, it depends on what quadrant you're in, whether you should add 180, subtract from 180, subtract from 360, or just keep the angle the same. So this little set of notes up here might be pretty helpful to you. All right, I'm going to stop there. It's mostly stuff you've done before. If you have questions, contact me. And if we have a lot of trouble, this could be something maybe on Wednesday. I do a little, I almost said Skype, Google Meet, and work through some of these with a group of students if need be. So good luck, talk to you later, and have a great day.